We're going to move on. This is Thursday, the 21st of January. We're going to move on to the next type of pulleys question, and it's exercise 21F. And I'm just going to show you the first question because the whole exercise is very similar. So if I show you the first question and then get you to work through the next few. So this is about pulleys where one of the objects, one of the bodies is on a horizontal table. Now you'll have to draw a sketch for each of these, and you have to take the information from the question to draw a sketch, but the sketches are all the same. So two bodies of a mass 7 kilograms and 8 kilograms are connected by a light inextensible string which passes over a smooth fixed pulley. So it's smooth, just like before, no friction in the pulley. The 7 kilogram body lies on a smooth horizontal table, so that's a new bit of information. And this is key. It's smooth. The horizontal table is smooth. And the 8 kilogram body hangs vertically. The system is released from rest. And then we'll have 3 questions to work out. So we'll look at our sketch first. So two bodies, one of them's on a table. The 7 kilogram body lies on the table. This is what our diagram is going to look like just on the left hand side. So all of the questions are going to look like this. Don't worry about what's on the right hand side just for now. So there's our 7 kilogram object, there's our 8 kilogram object. This object just operates in the same way as the previous exercise. So F equals ma. 8g minus t is equal to 8a. That's how we model that particular body. And that's because here's the direction of motion. The 8 kilogram body is going to move down. It's going to fall down. Now because it's falling down and there's a pulley here, notice that the direction of travel of the 7 kilogram body is to the right. It's going to go towards the pulley. Now what is pulling that object forward? Tension is pulling the object forward. That is the forward force of the 7 kilogram body, 7 kilogram object. Now usually whenever we have an object pulling along, there's going to be some sort of resistive force acting against it. But remember that this is a smooth horizontal table. So there is nothing acting against the direction of travel. So the resultant force is just the forward force. So let's just look at the notes I have here on the right hand side. We're still going to use F equals ma for both objects, the 8 kilogram object and the 7 kilogram object. So the question I have here, just what I was talking about, for the 7 kilo object, the one on the table, what is F? So the body is being pulled along by the tension in the string. There is no resistive force since it is a smooth surface. There's no friction holding it back. So the force pulling the object forward is T, and that's the only force acting on it. That is F, the resultant force. So T is equal to mass times acceleration. This is for the 7 kilogram body. So this T is equal to mass times acceleration. So there's our first equation. Just like we did in the previous exercise, we have an equation, F equals ma, for one of the bodies. Let's do the same for the second body, for the 8 kilogram body. This one is just exactly the same as the previous exercise. Force is equal to mass times acceleration. That's the resistive force. So it is the downward force, subtract the tension, 8g minus t. That is the resultant force, sorry. 8g minus t is equal to mass times acceleration is equal to 8 times a. So just like the previous example, previous exercise, we have two equations. Equation 1 for the object 7 kilograms, equation 2 for the object that has 8 kilograms, and then we combine them. So there's our two equations. Same again, add them together, this gets rid of the t's. So 8g is 15a, remember g is equal to 10 meters per second squared. So then we can work out our acceleration. So just go back to the questions. First question asked us for the acceleration. Second question asks us for the tension. Remember from the previous exercise, we just take one of these. So look at the tension in the string. We just take one of these equations, equation 1 or equation 2, and work out the tension. So for part B, tension is equal to 7 times acceleration, just from equation 1. We know this from part A. So there's our answer. That's the tension in the string. Let's look at question C. We are now looking at the force exerted by the string on the pulley when the bodies are in motion. So there was a similar question to this in the previous exercise. The only difference is that the tension is acting in different directions to the previous exercise. So I'm taking this sketch And I'm just going to redraw it down here. Now you don't have to redraw it. This is just to illustrate what's happening here. So I've just removed some of the information just so we can see what's happening. This arrow, this tension is pulling against the pulley in that direction. So that is a force acting on the pulley, that yellow arrow. There's also a force here, this other yellow arrow, pulling down on the pulley. So can you see that we have two tensions acting on the pulley? Now we know the value of those tensions. Those tensions are both the same. Now whenever we are asked to find the force exerted by the string on the pulley, what we're looking for is the resultant force. So if we're asked for the force, we know that there's two forces acting on it, but we're looking for the resultant force. Now just notice how I've arranged those two arrows. You arrange them nose to tail. So just notice that this, let me get the highlighter. This arrow here is the top arrow, pulling at the pulley. And then I'm going to take the second arrow and just put it here. So just draw your two arrows like that for all these questions to get the resultant force. Nose to tail. What do I mean by nose to tail? There's a nose, there's a tail. We know the value of the two tensions. How do you get the resultant force? You use Pythagoras. So I've just written here, perform Pythagoras' theorem with both short sides equal to tension. So for all of these questions, for every part C, you're going to do Pythagoras. A squared plus B squared equals C squared. So short method to work it out, you just take the two short sides, square them, add them, take the square root, and that's the resultant force. That's the force acting on the pulley. So there's our three types of question, A, B, C. Whoops. So key bits of information. There's our smooth fixed pulley, just like before, but now this is the new bit of information, a smooth horizontal table, no friction. We need the acceleration, we need the tension, and this is new. We have to perform Pythagoras to get the resultant force on the pulley. So I'll put this PDF up for you to read through. So once you've listened through this video, read through the PDF and try the questions that I put up on Google Classroom.